Welcome back to Learning Image Analysis. Our lesson today is about removing distractions from your image. So our two images, first we have our gold nanorods that we talked about several lessons ago. And then we also have a new image, one of some seeds. And by distractions, I mean the scale bar down here at the bottom of the image, and these labels that are present in the seed image. Okay. You often might find that you have an image with this sort of element in it, and that needs to be somehow excluded from your segmentation, from your operations. Of course, it would be best if you could get an image without a scale bar burned into it. That's not always possible. You don't always have access to the original data. And then often in doing field work, you do need to have this sort of labeling in the image just to make sure that images don't get mislabeled, mixed up, that kind of thing. So when I say distractions, I don't just mean things like scale bars and labels. I also mean perhaps scratches that run across the surface of your sample, or dust that happened to get onto your polarizer, or some sort of error like that that will interfere with your segmentation. And depending on the type of interference that you get, that will determine how you want to handle it, with grayscale preprocessing or with segmentation mathematics. Basically, do you want to remove the features before you segment or after you segment? And then when we get to the segmentation, particularly in the image of seeds, we'll discuss a concept of two-stage segmentation, where you have one set of criteria that defines what a feature is, where are the boundaries of this feature, and then another set of criteria that differentiates that feature from others. So how can we select seeds but not select labels, or vice versa, depending on what we're trying to do? So in this nanorod image, if you remember, we differentiated the nanorods from the background based on a simple basic threshold. And because we have such a nice pair of peaks here, with our nanorods being darker than the background, we can use an auto thresholding. Now this long tail to the nanorod grayscale intensity tends to pull our threshold over, so we'll want to adjust it a little bit. Say 20. That way we get these nanorods fully selected here. Okay. And that works pretty well. So this particular image doesn't really suffer a lot from having the scale bar present inside of it. But you can see a situation where it might. Perhaps instead of being just black and white, the scale bar was some shade of gray. Then it would fall here into where these peaks are and might cause this value to shift one way or the other. Also, if the scale bar was larger, currently it's only a small little portion here, so here's the white, it's not really interfering a lot. Here's the black over here, again, it's not interfering a whole lot. But I've seen images where the scale bar is across the bottom of the whole image. And in that sort of situation, you might want to remove these grayscale values because they could interfere with auto segmentation. So how can we remove this scale bar from the image? Well, we'll do that with a process known as Grayscale Reconstruction, and particularly in painting. What we can do is take the color that's surrounding the scale bar and diffuse it into this area and obliterate the scale bar itself. Now first we have to find the scale bar so that we can do that, and we'll just use a simple range threshold to, in a single step, two steps here, we just find the scale bars, just all the solid black and the solid white. Okay, I actually find everything but the scale bar in a single step, and then invert in a second step. But this gives us the scale bar selected. And now if I put the selection into our companion image and call back the original, we can use that for inpainting. So what this will do again is take the color that's on the edge of the scale bar and diffuse it inwards, just like so. And now all the blacks and whites are gone. And we can then take this image and use our basic threshold with an auto selection. And it gives the same number as previous because for this particular image, as I said, it doesn't suffer from the scale bar that much. But in some situations, this might be the best way to handle a distraction in your image, is to actually cut it out using grayscale in painting. So now let's move to our image of seeds here. And in this sort of situation, we're not going to be using a basic threshold, an auto-determined threshold to segment these images, particularly because the fibers get pretty dim here. And finding really dim features is not something that auto-determined thresholds do very well. If we basic threshold here, auto, you see how it really doesn't grab all those fibers very well. It puts us right in the middle when we'd like to be way over here. So since we're not going to use an auto threshold, we don't need to worry about inpainting. We don't need to worry about removing the grayscale pixels. Instead, what we're going to do is select all of these labels and then subtract them later from the seed selection. Now, in order to get these labels selected so we can subtract them later, we're going to use two-stage segmentation, which considers first what defines a feature, and second, what distinguishes that feature from other features in the image. So obviously, on its face, these labels are bright white, while the seeds are yellow, or in the grayscale image, they're grayish. So we might say, well, let's just select our labels based on their brightness. See bright white here. But that's not really successful, because in order to get enough of thresholds so that you're not inadvertently selecting too much of the seeds, you have to go high enough that there's a lot of material here on this ruler that isn't being selected. So just selecting only this bright stuff, only super bright things in the image, isn't sufficient. But this super brightness does distinguish these labels from the seeds. It doesn't define the entire label, but it distinguishes the labels from the seeds. So if we do a simple little cleanup here, remove some of the smaller segmentation, some small inadvertent selection inside the seeds themselves. Okay. And now we have a selection that just marks where the labels are. Okay. Now we can save this away and go back to our original, and we're going to use a different level of thresholding in order to select the entire label. Right? We want to select the entire label just like so. So this 62 value, this is what defines the feature. And this 250 value is what distinguishes these labels from the seeds. So now we'll do just a little bit of cleanup. First we have to make sure there's no inadvertent connections between these labels and the seeds. So if we erode a bit, say 5, and then dilate back out, a little bit here. Okay, and now we don't have any seed selection touching any label selection. And we're going to use our keep mutual function. So this only keeps selection that is also present in the companion image. So the companion image is marking all the super bright stuff, and then we only keep here complete selection that has selection in our companion. So now we have our labels selected. And this can then be used to subtract from the full seed selection. So if we set our threshold about here, about where we want it to find the seeds properly, and all the hairs inside of them, and we can subtract our labels, and here we go. We have our seeds selected without the labels interfering. And when you're doing this, you can use all sorts of criteria for this distinguishing characteristic. Perhaps you've got some sort of function that finds text, right? Or perhaps your labels have a lot of lines in them, or perhaps your labels or whatever it is that you're trying to find is very smooth compared to your other sample or your features that you want. You can do all sorts of tricks to try to get something that just touches only what you want to remove. And then you can use that to then get a better complete selection of the entire features that you want to remove. And then you can remove it. So today's lesson was a little bit shorter, but we talked about some very powerful techniques. Grayscale Reconstruction first, and then two-stage segmentation. That two-stage segmentation really can unlock the ability to automatically segment some pretty difficult or some pretty complicated features in your images. So I very much encourage you to try to get that sort of thinking, that iterative thinking under your belt. Speaking of iterative segmentations, in next lesson we'll be talking specifically about how to use multiple segmentations and combine them to get a really nice, clean segmentation of some of your features. So I'll see you then.